we're going to talk about something called Pascal's triangle. So this is something you maybe have seen before. It's just this, this sort of like infinitely big triangle that has a really particular pattern to it. So what I've done here is drawn the first four, I'm going to say four for a reason, but the first 4 rows of Pascal's triangle. And so just to explain why I'm saying 4 here, we're actually going to call this top row the 0th row. And so this will be the first row, second row, etc. And there's a reason for that, which I'll explain in a little bit. And basically what you'll see is that we obtain every new number, or like every new row, by adding the 2 numbers above it. So for example, this 4 can be obtained from 1 plus 3. And this 1 here is 1 plus, well, there's nothing on the other side, so it's just going to stay 1. So we can keep generating rows here by following that pattern. So the next row is going to be 1 plus 0 is 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and 1 plus nothing is 1. And yeah, so we would just basically complete, just keep doing these rows like this, and you could go on forever, and you'll obviously get bigger and bigger and bigger numbers. So something else that we'll say is if we're talking about the entries of the row, generally what we'll do is also start with the 0th entry. So this here is going to be the 0th entry. And then this 10, for example, would be the second entry. And maybe this 5 would be the 2, 3, 4th entry. And that last one would be the 5th entry. So there's a particular reason why we're going to start with zeros, and it has to do with a certain pattern that we might notice. So what I'm going to do at the same time is evaluate a bunch of those C formulas. All right, yeah, so we're going to evaluate actually all the possible C formulas for a top of 5. So the numbers should range from 0 to 5. And so if I do this, so 5, 0 is going to be 5 factorial over 0 factorial, 5 factorial. I don't know if I specifically mentioned this before, but 0 factorial is just going to be by default the number 1. If you think back to the definition of factorials, 0 factorial would be basically the number of ways of arranging 0 distinct objects. Well, there's one way to do it, and you do nothing because there's nothing to arrange. So it kind of makes sense in that phrasing, but it's also just going to make sense for all of our calculations. So yeah, so we get this. You can see since the 0 factorial is actually just 1, what we'll get here is that everything should just kind of wipe itself out. And so we're going to get 1 for that number. 5 choose 1 is 5 factorial over 1 factorial, 4 factorial. So 120 over 1 times 24, which is 5. 5, 2 is 5 factorial over 2 factorial, 3 factorial, which is 120 divided by 2 by 6. So that'll be 10. 0 looks pretty bad there. And maybe you're seeing the pattern here. 5, choose 3. Now, if we look at this one, that's 3 factorial times 2 factorial. If I'm following the pattern, that's the exact same thing I got in the previous calculation. So that's actually 10. And then 5, choose 4 is just flipping the 4 and the 1 up in the 5, choose 1. It's just the exact same thing, just a different order. So that's going to be 5. And then 5, choose, sorry, that last one should be 5, not 1. So that's going to be 5 over 5 and 0. And so that's going to be 1. And so the significance of this is that if we look at the pattern here, hopefully you see it over there on the left. So what you actually end up getting is exactly the entries of Pascal's triangle. And so there's a nice little result of that. And so the nice result that we get is that, so if we follow this labeling that I gave you, so I chose that top row to be the 0th row so that this red one here is actually the 5th row, according to that. And then if you read across, we can see the 0th entry, the second entry. So that's my 0th entry, my second entry, my 4th entry, and my 5th entry. The numbers on the bottom are corresponding exactly to the placement if we start counting by 0. And then that row number is what gives us the top number. And so, in fact, the kth entry of the nth row of Pascal's triangle is exactly n choose k. So this is actually going to tie back to something that we would have talked about when introducing this combination formula and an identity that I have actually proven in that video. So this identity here for that combination formula is actually always true as long as you choose your k to be less than, as long as k is an integer such that it's at least 0 to, should be n minus 1. So as long as we choose k in that range, this identity is going to be true. And so this is actually completely consistent with this pattern of Pascal's triangle. So if I actually go and pull the numbers, or maybe try to draw them in here, if this 5 were my n plus 1 k plus 1, and then you can see the two numbers up here. So this 4 is, it's 1 less n, so it's going to be n. And then if you look, it's 1 less across, so that's going to actually be nk there. And then this 1 here is going to be my n and k plus 1. And so those two things are going to always add together to give us the next one. And so basically that allows us to just completely keep generating and showing that all of these numbers are actually going to follow this pattern for us. So hopefully you'll believe it because of that. All right, so just to wrap up, just a quick little question that we can do this. There's not really that much that we can do with this Pascal's triangle except acknowledge that it's kind of cool. But this is maybe a question that could be asked. Find the 5th entry of the 12th row of Pascal's triangle. I don't really like asking these questions because I'm not, completely making it clear that I'm using my weird row numbering system of starting with 0, but we'll just assume that I am for this and just I won't ask you one of these on a test, basically. But essentially, we're just going to use that formula down here. What that's saying for us is that it's n equals 12, k equals 5, and so we just plug it in. It's going to be 12, 5, and I'll do that on my calculator. I get 792. So I could have done it by going through and doing like a horrible amount of row drawing. Like I could have just gone through and kept adding the numbers until I have 12 rows, but you do start getting a lot more numbers and that would be a little bit tedious. This is a nice, clean, quick calculation for that. So yeah, that's about all we can do with this triangle. It will show up if you were to do lots more math, but for right now, it's just kind of neat.